In this lesson, we will examine some techniques for solving equations involving fractions. Let's begin with this question. To solve this equation, we will use the fact that when we multiply a fraction by its reciprocal, the product is 1. So if we take our equation here and multiply the left-hand side by 5 over 2, we have 5 over 2 times 2 over 5, which equals 1. So the product here is 1x, or just x. Now if we multiply the left-hand side by 5 over 2, we must also multiply the right-hand side by 5 over 2. When we multiply 8 by 5 over 2, we get 20, so the solution here is x equals 20. Now please note that we can express fractional coefficients in more than one way. For example, writing 2x over 5 is the same as writing 2/5 times x. Okay, let's try another one. Here the coefficient of x is 3/4, so we'll multiply both sides of the equation by the reciprocal, 4/3. Now on the left-hand side, the fractions cancel out, leaving us with x. And on the right-hand side, 1/7 times 4/3 is equal to 4 over 21. So the solution here is x equals 4 over 21. Okay, now let's examine a more advanced question. Our goal here should be to eliminate our fractions first. We can do this by multiplying both sides of the equation by the least common multiple of the denominators. So in this equation, the denominators are 4, 2, and 3. Since the least common multiple of 4, 2, and 3 is 12, we will multiply both sides by 12. Now I will write 12 as 12 over 1, so you can see that we are multiplying fractions here. Now at this point, we need to expand the left-hand side. So first we will multiply 12 and 3x over 4 to get 36x over 4. Next we'll multiply 12 and 1/2 to get 12 over 2. Now I could have simplified these products, but I'll do that in the next step. On the right-hand side, we'll multiply 12 and x over 3 to get 12x over 3. At this point, all of our fractions simplify nicely. 36 over 4 is equal to 9x, 12 over 2 is equal to 6, and 12x over 3 is equal to 4x. Now that we have eliminated the fractions, we have a relatively simple equation to solve. From here, let's subtract 9x from both sides. And now we'll divide both sides by -5 to get x equals 6 over -5, which we can also write as x equals -6/5. Okay, here's another example. Once again, to eliminate the fractions, we'll multiply both sides of the equation by the least common multiple of the denominators. Here, the least common multiple of 10, 5, and 12 is 60, so we will multiply both sides by 60. From here, we will expand both sides beginning with the left-hand side. 60 times x over 10 is equal to 60x over 10, and 60 times 4/5 is equal to 240 over 5. On the right-hand side, we'll multiply 60 by x over 12 to get 60x over 12, and we'll multiply 60 by 1 to get 60 over 1. At this point, all of our fractions simplify nicely. 60x over 10 equals 6x, 240 over 5 equals 48, 60x over 12 equals 5x, and 60 over 1 equals 60. From here, we can solve for x by first subtracting 5x from both sides. And now we'll subtract 48 from both sides to get x equals 12. Now here's a more advanced question. To eliminate the fractions here, we'll multiply both sides of the equation by the least common multiple of the denominators. The least common multiple of 2 and 3 is 6, so we will multiply both sides by 6. Now let's expand the left-hand side. 6 over 1 times the first rational expression is equal to the following, and 6 over 1 times the second rational expression is equal to this. On the right-hand side, 6 over 1 times x is equal to 6x over 1. At this point, notice that 6 over 2 here can be simplified to be 3, and 6 over 3 can be simplified to be 2. Finally, the right-hand side simplifies to be 6x. Okay, we have now eliminated our fractions. Now we need to do some expanding. First, 3 times 3x is 9x, and 3 times positive 2 is positive 6 or plus 6. Next we have negative 2 times x, which is negative 2x or minus 2x, and we have negative 2 times positive 1, which is negative or minus 2. This is all equal to 6x. At this point we can simplify the left-hand side to be 7x plus 4, and now we can solve for x by first subtracting 7x from both sides, and then dividing both sides by negative 1 to get x equals negative 4. Okay, let's examine one last question. For this question, it seems difficult to use the technique of multiplying both sides of the equation by the least common multiple of the denominators, since it's hard to tell what is the least common multiple of 6x minus 6 and 2x plus 2. Now, whenever we have two rational expressions set equal to each other, we can use the following extension of the least common multiple rule. It says, if a over b is equal to c over d, then it must be true that a times d is equal to b times c. In this equation, there are two equivalent rational expressions, so we can apply this rule and conclude that 7 times 2x plus 2 must equal 3 times 6x minus 6. At this point, we have a nice equation that we can solve for x. First, we'll expand the left-hand side, and then we'll expand the right-hand side. Then we can subtract 14x from both sides, and now we can add 18 to both sides. Finally, when we divide both sides by 4, we get the solution x equals 8. Okay, let's summarize. Some basic equations can be solved by using the fact that the product of a fraction and its reciprocal equals 1. Also, we can eliminate fractions by multiplying both sides of an equation by the least common multiple of the denominators. And finally, if we have two rational expressions set equal to each other, we can cross-multiply and then solve the resulting equation.